Hello everyone, welcome to another video in the Raspberry Pi 4 bare metal assembly programming tutorial series. So today we're going to have a short video for you, which is exciting I guess. And in the last video we were able to blink an LED light on and off by using GPIO21. Originally for this video, which is now going to become the next video, I was going to generalize our code. So instead of GPIO21, we would be able to use any GPIO pin that we wanted. Or I should say any pin that we had access to. There actually are a bunch that are just internal to the board. Anyway, it occurred to me that you might want to actually start writing your own code and debugging things. And the way you debug often is you get some sort of output from the computer telling you whether or not the thing you're expecting is happening or it's not happening. Because when you're programming an assembly, you're going to be assembling, saving, running the Raspberry Pi, finding out if it works or not, and then repeating if it doesn't work, or moving forward if it does work. So anyway, enough chit chat, let's get into it. You should recognize all of this code. This is the code we had from the last video. And the major parts are this will set up our pin as an output, this will turn the pin on, this will delay, turn off, delay, repeat. So we're going to take advantage of some of this code. We're going to call this LED off. And instead of that, we'll just put in an exit loop and do an infinite loop exiting. And let's copy this code. We will want a branch to exit. We will call this one LED on. And it won't need the branch anywhere. It'll just overflow into exit. Now let's say that we want to work with, we'll work with W2 because we don't want to touch X0 or W0 because that's where our base is, and that's kind of important. I guess we could work with 1. We're done with 1 for now. 2 and on up, except for the special purpose registers, we'll use 2 in this case. Let's say we have the number 1000. And we want to see if the number 100 is less than 1000, let's say. So W2 compared to 100. Now this number is the mysterious number. This number might have been derived by doing a bunch of different math equations. Maybe you loaded it out of a memory address. We haven't talked about that yet, but it'll be coming. Maybe you loaded out of a memory address and you don't know exactly what that number is. This is the number we don't know. So in this case, let's say if whatever this number is greater than 100, we'll do a branch greater than, go to LED on. So this will turn on the LED and it will just stay lit no matter what. Now, if it is not true, it'll overflow and go into LED off. So it'll actually turn the LED on momentarily. And then after that, it will delay and then turn off and never turn back on again until we unplug it and plug it back in again. Now, there actually is a third option. The third option is an LED light never turns on. The LED never turning on, assuming that your circuit is set up right and that you didn't change any of that. If it never turns on, that means that the program crashed. So we did something, the assembler didn't catch it, but the program completely flat out crashed and the light didn't even come on. That means that the code is broken even before our debugging. So those are 3 options. LED never comes on, program crashed. LED turns on and then turns off and does not ever come back on. That means that whatever we were checking here is false. LED turns on and stays on. Whatever we were checking here is true. So let's try this out. We know that this should be true because 1000 is greater than 100. So we have that saved. Let's open up a new terminal. $100, very nice. All right, so we have that. Let's test it out and make sure it works. Okay, so let's test if this works. We will plug it in. And once it's done booting, we should get a steady LED. So it's booting up. And there's the light. It is steady, which means our statement was true. All right, very cool. So that worked the way that we anticipated. Next, let's do the opposite. Let's say if it's less than, so this would be a false statement, just to show you how that would work. We will assemble this again and test it out in the real world. Okay, now in this scenario, we're going to see if the statement was false. So again, we'll plug it in. And wait for it to boot. Now what it should do is it should turn on and then turn off. So there it's on and now it's off. And that means that our program didn't crash because otherwise it would have never turned on. All right, very cool. So that all worked. That's all that I have for you today. Like I said, this was going to be a short video. I hope you found this video enjoyable, educational, and that makes you excited about being able to program on your Raspberry Pi. And we look forward to seeing you in the next video.